I haven't had a whole lot to say lately, but I was watching some stuff on like digital sampling and stupid shit like that, and I thought about the old paper about how pixels are not little squares, and it was written by a dude that you may not have heard of him, but you probably heard of a little company he's worked for known as Pixar. Yeah, actually, I'm pretty sure he's the founder of the company. It's like a 95 paper, so I was like 4 years old when it got written. Um, but I've spent like 20 years being into computer graphics, video encoding, image processing, all that stupid shit. And so I actually just had a little experience earlier where basically I got fucked out of my login for an app on my phone, and I wanted to try to look through the data that I copied off the phone to see if I could find any sort of like remnants of the login, because I can't find it any other way. But part of the backup that I made, like one of the app's files, was called bitmap cache, and none of them even had a file. Like, well, they ended with like .0 or whatever. But I thought, I wonder if these are actually like files I could look at. And I could have tried this first and just renamed it .jpeg, but I opened the file in a hex editor because I know that these image formats and all that have a header to them. And the first thing you see on there, it says like JFIF, JFIF. And I looked up the list of, like, Wikipedia has a page on like different image format headers, and sure enough, that's the image format header for JPEG. So when I changed it to .jpeg, it worked, right? That was sort of a little, kind of somewhat related example. That's his whole video if I even decide to make one. But so I've been into image stuff for over 20 years at this point, and it still amazes me like how few individuals really understand what sampling even is. And if you go and look up pixels are not little squares, you're going to see there's multiple Hacker News articles over the last like 10 or 15 years. There's at least two or three of them. And there will be people in the comments arguing about it and how the guy didn't know what he was talking about. And one of the common ones I see is where people will say, well, but here's this context where they treat it as if it's a little square. And it's like they all miss their own point when they say stuff like that. But it's like, and I feel like the title of the paper, yeah, clearly it's meant to be a little bit sensational and attention grabbing, but I feel like it should have just straight up said the point in the title. And so because I was thinking about analog video and the concept of non-square pixels, which doesn't exist. Like the closest thing you might call it is like non-square pixel spacing. But the digital handover from old school analog video, they took how many microseconds is the line, right? Because like in ntsc, there's like 525 of them. The line, including the horizontal blank, is, I don't know, it's like 60 something, microseconds. Well, the sampling rate, basically, like whatever that percentage, I don't know, it's like 90 something percent of I don't know, whatever, the exact range of that horizontal line, right? Across the visible area there. Or actually, no, I'm pretty sure the digital sampling is for the entire, like, side to side, including H blank. But that's its own problem because most stuff just ignores it. But like that sampling side to side for a single line, the sampling rate, which they picked as, it's basically 720 for both formats. Across that line, how many samples, and what they do is it's just the duration of that line divided by 720. So however many nanoseconds that is, that's where a sample is taken. That's it. And it's like the reason it looks incorrect on your computer screen or whatever is because the point of the sampling was not to preserve the geometric relationship. It's the same number of scan lines, but it's an arbitrary number of samples across any individual scan line. So the horizontal to vertical has nothing to do with that. The only reason it has the geometry it does on the television is because of just how long it takes it to get from one side to the other, right? So like back in the day, I had one of those breakout things for my 360, which I had one when it was like R-Rod shit. So I ended up, you know, like I got rid of it. But way back when 360s were pretty new, I had the thing to convert to VGA, and I would hook up my CRT monitor to it. But when I set it to 720p, which is why I wanted it, it would be stretched too much vertically. Well, how do I fix that? Well, you just squish the geometry vertically till circles look like what you would expect circles to look like, right? You see that a lot with, oh, was the aspect ratio supposed to be this or that? It's like, well, the aspect ratio was whatever looked correct on the screens they made it on. Maybe some developers considered more so the consumer level side of that, what it would look like on like the end user screen, or what. Not all of them did though. So, but I can almost guarantee you a circle should look like a circle. Um, but it's like it's not about what the storage format is. That's just the ratio between the horizontal and vertical pixel count, which is not the same thing as the actual screen geometry. It was more obvious in the past because you didn't, now you have fixed pixel displays, but I don't know. I was looking, so I started with shit like that, and then I was just thinking of aspect ratio in general, or like pixels in general. And I thought of that paper. I read it occasionally, but so I was searching YouTube. It's like, has anybody else made videos about this? And I found this. It's like an online presentation. It's from like 2020 or something, like Chomo Central Times. And I sat there and I watched it, and it's like the most agonizing thing I've ever watched. I even left it this really fucking long comment that they either never read or Google nuked it or they just deleted it or whatever. But I said that was like the first thing I say in my comment. It's like all these examples you're giving, it's like, well, but here's where it's like, the pixel on the screen is a square, or this. It's like, but the point of the paper, and I feel like he should have said it like this. It's like a pixel is not a little square. Your representation of it is. Because one of the comments I seen on one of the older Hacker News articles, Y Combinator or whatever, was they were saying, well, but the guy that did the first digital image scan separated the image into little square areas and this, that. And it's like, well, yeah, exactly. That was his representation. That can't be the pixel because a pixel is zero dimensional. It's a point sample. It has no volume. It has no area. Your representation of it, maybe in the digital format, it's an element in a two-dimensional vector space, and it's represented on a screen, which is a real-world object that has volume to it. Even those little pixels, yeah, like they're on the screen, they're kind of like nominally flat, right? And you could think of them as a two-dimensional array, but even those, they're really, really thin on the like third axis, but they're still volumetric. Like even graphene transistors, they call them like two-dimensional transistors. What they mean is they're one atom wide. Well, sorry to break it to you, but even an atom has a volume to it. It's really, really small, but that's not the same thing as zero, is it? Right. But it's one of those things. Like it seems like it should be so obvious, or maybe it's like too obvious that everybody just doesn't get it. But I mean, that's the thing. All the pseudo counterexamples are just proving the point. So you might take these you're using physical objects to take the samples, and maybe you arrange them in an orthogonal lattice, but that's not the same thing as the sample itself, right? It's like a line. Something I was thinking about, which might end up being its own video, was like, how do you determine whether or not an object will fit inside a bag, right, or any other kind of occupiable volume? But it's like, you imagine you had a duffel bag and you want to put like a camera tripod in it. It's like, will it fit? And it's like, well, you need to know the dimensions of the internal space. Let's assume it's cuboid. Okay, well, if it's longer than the longest axis, now you got to find, I would call it the three-dimensional hypotenuse. Apparently that's not a real term because I was trying to look for it. And they say, well, hypotenuse is for 2D, and in 3D they just say the length of the diagonal. And then I'm like, but a hypotenuse in 2D is just the length of the diagonal in 2D, right? I was trying to look that up as well in this context. It's like, okay, what would you call a chord in context of a cube? Because, like, if you do a polygonal approximation of a circle, you're basically, you pick the vertices from the center, and it's the inscribing line. The short end of the short side of the triangle will be the chord, basically. But it's like drawing a line on the inside of the circle. So it's like kind of like you could think of it as like the opposite of the tangent. Well, they said that as well. Oh, that term does not exist, blah, blah. It's like, but you know what? If I describe it like that, you probably know what I was talking about, right? But, it's a similar thing. So basically, if you measure the length of the object and then you determine, okay, well, the length of the diagonal, or I would call it the 3D hypotenuse, it would fit that way. But then the question is, would it though? Because what you have is a line measurement, and that's the same problem. The line is one dimensional, but it has no thickness. Well, chances are the object you're probably trying to put in the bag does. So, you would need to know the volume of the object as well, and then imagine a center line through the longest side, the longest axis, that center line, and then give or take on either side. So, if just the raw numbers math out, that doesn't necessarily still mean it could fit, right? So it's the same kind of thing though. A line, people, when they draw lines, yeah, you can see it, but you can only see it because there's the thickness to it that the actual element itself doesn't have. That's your representation of it. You can make a line and vary the thickness and all this other stuff. If you got a program like GIMP or whatever, you can do like the calligraphic stuff where it like tapers off. But again, that's a representation. The line itself, it's just a concept. But if it's the same thing with voxels, volume element. Yeah, well, you can take any volumetric object, kind of broadly chunk it up into little cubes, and all right, inside each one of these little cubes, that's where the sample position is. But the sample itself is zero dimensional. A point sample has no anything. But, again, you're trying to comprehend where the sample is at, so you have these kind of crutches like this. But it's not the same thing as the sample itself. I don't understand how. Like, it just seems like it's so obvious. And the same thing, the problem I have with that presentation I looked at is, like, I even said that, like, this very clear they had no idea. Like, here's all the stuff they're giving a presentation on something that they frankly don't know anything about. But it's like, it was only like the first 5 minutes where he's even talking about the pixels being squares or not bullshit. But then the rest of it is stuff that, like, really has nothing to do with that. He was talking about, like, texture filtering, and then reconstruction filter risk, transfer functions and all this other stuff. And then he was even talking about, well, some displays have hexagonal shaped pixels, or like you can make the pixels different shape. It's like, dude, that's not going to change the amount of aliasing, because again, the shape of the quote unquote pixel is the shape of the display, and that's only representing the sample positions. Like the sampling itself is, like, whether or not it has aliasing is going to depend on the sampling rate versus, the transfer function of the reconstruction filter or low pass filter or whatever. And then to some degree, the sort of direction of the sampling, right? So, like, for an example, your retina has a Poisson disk distribution, this like blue noise arrangement. But just like PCF and shadow maps, or different like jittering algorithms like that, that just translates some of the aliasing into noise. But that's not just, it's not like changing whether there's aliasing or not. And it has nothing to do with what a pixel is. But I'll just leave this video on that and just kind of make that point. Like, reiterate it, just to really get it across. A pixel is not a little square. Your representation is.